Assalamualaikum and hi. My name is Muhammad Aizat bin Muhammad Ramli and my teammate is Muhammad Zuhilmi, Muhammad Nofaiz and Muhammad Afnan Hamimi. We are from Group 2 in Section 41 and the data that we get is Lajak Kuruih-F that we must to solve the problem. For the introduction, as you can see in the slide, our group is in chain of monitoring the quality of tablet production for type F of Lajak Kuruih tablet. In the next part, we will perform a statistical analysis for the dataset 200 sample observation taken at random from 3 production shifts run daily, which is morning, evening and night in December 2020. Bismillahirrahmanirrahim. I will explain about part A first. Firstly, for the data given, we must separate by each group which is have morning, evening and night. By using pivot table in the Microsoft Excel, we can summarize all 200 set of the data given and can be easily construct in frequency data. The pivot table also can set the range of the row label as you can see in table 1, table 2 and table 3. For the pivot data, we must do for the data of weight, relative density and tensile strength. Next, we go through for the weight data first. As you can see in the table for the weight as stated in table 4, for the frequency data is come from the pivot table data. We also can find midpoint, means, variance, standard deviation. Same as the table for relative density and tensile strength in table 6. After that, when all the data in the table of Lajak Kuruih-F has been calculated, we plot the graph by using the raw label and frequency data. As you can see in the graph of weight in figure 1, the graph show increase linearly until reach the range 350 until 360 and then decrease linearly. The highest of the data frequency is 53, which is at the range 350 until 360. Next, for the graph in the figure 2, which is graph for relative density, show the same result, increase but a little bit higher at 86 until 87. The graph show decrease, start from 89 until 95. The lowest of the data frequency is 1, which is at the range 82 until 83 and 94 until 95. Finally, for figure 3, show the graph tensile strength. The result show increase linearly until 7.1 until 7.2. After that, the result is scattered because show going up and going down. The lowest frequency show at 7.6 until 7.7 and 7.7 until 7.8, which is 2.
Assalamualaikum and hi, my name is Muhammad Zuhaimi. FDA authorities require that the weight of standard tablets produced by manufacturers should be normally distributed with mean 350 mg and standard deviation of 14 mg. We have to test the sample of data of Lajak LAKU tablets whether it meet the expectation or not. So, the goodness of fit test is used to check the distribution of Lajak LAKU sample data. We set the null hypothesis, which is H0, is the weight distribution that follow the normal distributions, and the alternative hypothesis, which is H1, is the weight distribution that does not follow the normal distributions. We reject H0 if chi-square is greater than critical values. First, we need to collect the data by creating a frequency table with suitable range and values as shown in Table 7. Next, from Table 8, the expected frequency is obtained by multiplying the probability with the total of frequency. The expected frequency should not be lower than 5. We have to add 2 or more subgroups to make it more than 5. As we can see from the table, the first three values of observed frequency is added as well as the expected frequency to get the new values for both parameters. After that, we can compute the value of chi-square test from this formula, and the total is equal to 2.4123. Next, we choose 5% as the significant level, which is alpha is equal to 0.05. From chi-square distribution table, we obtain the critical value is equal to 11.0705. It can be said that the chi-square calculated in table 8 is lower than the critical values, so we do not reject H0. To conclude, there is significant evidence at alpha is equal to 0.05 that Lajak Laku tablets produced in December 2020 follow this normal distribution. The Lajak Laku tablet do follow the FDA requirements.
Bismillahirrahmanirrahim. My name is Muhammad Nafais. I will continue for the part C. So this is a Lajak Kuruih-F, which is operated with three different shifts, which is morning, evening, and night. So the total sample data here is 200 sample data. So I rearrange the data according to the shift, morning, evening, and night. After that, I will get this important table of tablet weight to form the ANOVA table. One way ANOVA table, this one. For the question C, comment on whether there is any significant difference between tablet weight from the different shifts, which are morning, evening, and night. So this is one-way analysis of variance table. For the null hypothesis H0, mu1, mu2, and mu3 is equally. For the alternative hypothesis H1, I not equal to mu_j for at least one ij where I not equal to j and ij equal 1, 2, or 3. For the SST, SSTRT, and SSE, we need to get the value which is already obtained from the one-way ANOVA table, which is sum of square total, sum of square treatment, and sum of square error. Decision rule: reject H0 if F calculated greater than F critical. So the decision is since F calculated is lower than F critical, so we do not reject H0. So the conclusion, we can conclude that at alpha 0.05 level of significance, that there is no significant difference in tablet weight from the three different shifts, which are morning, evening, and night.
Okay, for the part D, it's about the simple linear regression. There is a relationship between tensile strength and relative density. So we can say that the tensile strength is depend on the relative density. Tensile strength also is a respondent while relative density is a predictor. So by using Excel, we can describe the data for these two parameters. Here we get the relative density percent in percent of line fit plot. This is the graph. Okay, next from the Excel also we get the summary output. From the summary output, we can get the value of the multiple arc, which is 0.844735. This indicates that it has a strong positive linear relationship between of these two these criteria. Okay, for the value of R square, in terms of percentage, we get the 71.36%, which is shows a good fit for the data to the regression mode. Okay, to test the linearity of relationship, we can use this hypothesis test. Okay, after that, we use the ANOVA test to find the value of significant F. Because our decision is to reject as known if the p-value is less than alpha. The value of significant F is also same with the p-value. So this is a value of p-value, and then the value of alpha is 0.05. So we reject the hash known. To conclude, the linearity significantly exists between tensor strength and the relative density at alpha equal to 0.05. Okay, for this table, we can get the value coefficient of alpha and beta. So for these two value, which is alpha is equal this value and beta is this value. So from these two values, we can get the fitted simple linear regression equation. So the equation becomes this, like this. Okay, for to predict the value of 68%, 74.3%, and 80.1% of below relative density values, we can use the data and enter it on this equation, so we get this value of tensile strength. But however, the range of relative density for this data is only between 82.9% and to 94.3%. So only for this range is valid to estimate the data. So our model is not valid to carry out for estimation for relative density, which are 68%, 74.3%, 80.1%. So that's all for me. Thank you. With the end of my presentation, it shows that our group is at the end of the presentation. So with that, thank you.